Hello, geometry students. This is 7-3, proving triangles similar, continued, so you will need your notes from yesterday. And we're starting off with a make sense and persevere problem. The question is any additional information needed to show triangle DEF similar to triangle RST? So we're going to look at these triangles DEF and RST. We need to know if the angles are congruent. Well, we have S congruent to angle E. So we can write that like we did, or we saw yesterday. Angle E is congruent to angle S. But are the other angles congruent? So I'm going to figure out what angle D is. 180 take away 85, that's 95. 95 take away 55 is 40 degrees. So that shows that angle D is congruent to angle R. Angle D is congruent to angle R. That is enough for us to prove the angle-angle similarity. And that theorem, which we learned yesterday, proves that these two triangles are congruent. So we would say triangle DEF, is not congruent, is similar to triangle RST by angle-angle side. Moving on to side-side similarity theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. And we saw that yesterday in our exploration. I showed you how to demonstrate this. So let's look. We have AB. And we're saying that AB corresponds to DE. Then we have BC corresponds to EF, and AC, if you have highlighters, you can use those to also do this, corresponds to DF. If that is a proportional relationship, so the cross products are equal, then the two triangles are similar because they have a proportional relationship. In triangle ABC, so we're going to go over to these problems. A equals 3, so I'm just going to label this to help us out. B equals 4, and C equals 6. In DEF, D equals 9, E equals 12, and F equals 18. We want to know if these two triangles are congruent. And so I can set up a proportion to say, I keep saying congruent. We want to know if these two triangles are similar. And we can set up a proportion to do that. But I can kind of see already that we can get 4 to 12 by multiplying by 3. And 3 becomes 9 if we multiply by 3. And 6 becomes 18 if we multiply by 3. So there is a common ratio. So yes, because, yes, the triangles are congruent. So yes, triangle ABC, I did it again, not congruent, is similar to triangle DEF. Congruent would mean they're the exact same. They're not. They are similar. And that is because, and we'll just show this as that proportion. So AB, which is 6, corresponds to 18 by a factor of 3. And that is equal to B to C, which is 3, to EF, which is 9, and AC is 4, and DF is 12. So all of these show they're all equal to each other, and each fraction reduces to 1/3. Next problem. Are ABC and DEF similar? So similar thing, just a little bit more difficult to see. But if I look at AB, that is corresponding to DE because they're both that vertical. These are right triangles. 3 is to 4.5. And does that equal 4/6? And does that equal 5/7.5? So basically, if I reduce all of these, are they equal? So I can do that by dividing, I can do that by cross multiplying. So 3 divided by 4.5, that's 2/3. 4 divided by 6 is 2/3. 5 divided by 7.5 is 2/3. So yes, because they all equal 0.67, or 6 repeating. Maybe I should just write that. 0.6 repeating, which is 2/3. Yes, triangle ABC is similar to triangle DEF. This next problem with side similarity is a little bit more challenging. We're looking at triangle ADE, and we want to know if it is similar to triangle BDC. So let me just highlight those. We have ADE, and we have BDC. So let's set up a proportion and see if it is proportional. So we'll set up a ratio and see if it's proportional. So from A to D, that corresponds with B to C. Those are both equal to 2.4. Then we have E and D, or E to D, and we have C to D. E to D is 1.8. C to D is 1.4. Well, if you were to just divide these, you would see that the first one equals 1. And the second one, I need my calculator for that. So 1.8 divided by 1.4. I get approximately, I'm going to make this squiggly to show approximately 1.29 if I round it. Are those equal? No. So it does not show a proportion, so not similar. The triangles are not similar because it's not showing a proportional relationship between their two corresponding sides. Next we have side angle side similarity theorem. So the last one was side side side. This one's side angle side. If an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then they're similar. So we have this example where we have the angle B is congruent to angle E. Then we have side AB is congruent to side DE, is corresponding to. And BC corresponds to not that one, EF, then they are similar. The two triangles ABC is similar to triangle DEF. If we have those three things true, that the two sides create a proportional relationship, so the sides are proportional, and we have the included angle congruent, then they are similar. So let's use this theorem to prove or to figure out another side of a triangle. We have angle L congruent to angle L. We're going to write this as a proof. Angle L is congruent to angle L by vertical angles, because vertical angles are congruent. Then we want to see what side MN is, and we're going to need to make an assumption. So, oh no, we don't, because we have the two sides. So we have side JL is corresponding to side ML, and that is 75/1. That's given to us right. Let me use a different color. Here. Then we have K and L, and we have L and N, but the little like similarity marks are telling us that those are the same numbers. So K L over NL, those two sides, KL is 75 also, and L is 1, or NL is 1. So those both equal 75 when you divide them. Therefore, we know that the two triangles are similar, and since we know that the two triangles are similar, we can now figure out MN. And how will we do that? Well, we're just going to set up a ratio problem. JK is equal to 10. MN is what we're trying to figure out. These two sides are corresponding. Right? JK and MN are corresponding sides. Now we just need to set up a proportion. So we'll take, we'll just write it like above. JK is to MN as JL is to ML. Just using the purple, what we had in purple. And then these were blue. Let's just plug in the numbers for those. JK is 10, MN is what we're looking for. JL was 75. ML is 1. Now we just cross multiply and divide. So 1 times 10 is 10. 10 divided by 75 is 0.13 repeating. So MN is equal to 0.13 repeating. And that's our final answer after we've proven that the two triangles were similar. That was the first step we did up above. Then we set up a proportion to figure out this missing side over here. This completes your notes for 7-3. Please begin your 7-3 assignment and complete it today.